All right. Hey, everyone. Welcome to the VS Code live stream. My name is Sana Ajani. Now, I'm a program manager on the team, and I know normally I'm behind the scenes, and you're probably expecting the ever so charming Burke Holland to be hosting this right now, but I'm filling in for him today, and so I'm excited to host this live stream and bring on our guest today. A couple of reminders. First off, join us on YouTube and join us on these live streams. So if you go to code.visualstudio.com/livestream, that's where you'll see the list of live streams we have upcoming. I know that we have our release party coming up next week or the week after, so stay tuned for that as well. And also make sure you subscribe to us on YouTube so you get notifications about all the live streams that we have and all the videos we're posting. And lastly, join us on TikTok because that's where the real party is. That's where we host a lot of our short tips and tricks to get the most out of your VS Code experience. So without further ado, I'm going to invite another program manager from the WSL team, Craig, to join us.
Hello. Hey, how's it going?
I'm good. So you're on the West Coast, right?
Yep, I'm all the way over near Seattle.
All right. Well, thanks for joining us bright and early. So tell me a little bit about what you're going to talk about today.
So I'm going to be talking about how you can use the Windows Subsystem for Linux, or WSL, to do a really awesome Linux-based workflow inside of VS Code using remote containers. We're actually going to be teaching AI. Well, the AI is going to teach itself how to play Atari's Brick Breaker, which is really cool.
So just a quick primer for maybe some people who might be new joining us. Can you just give us a quick primer on what WSL is?
Yeah, so WSL stands for the Windows Subsystem for Linux, and it is a really powerful way for you to use Linux workflows, applications, command line tools, utilities, all directly on your Windows machine. And where it's really different than traditional VM setup or dual booting is it has a really high level of integration between Windows and Linux, so you can access everything back and forth and share things like even your GPU access, which is what I'll be demoing today.
All right, so truly cross-platform development.
Exactly.
Okay, cool. So I'm going to go ahead and get your screen up and take it away.
Awesome. All right, so I'm jumping in over on my screen. I've opened up Windows Terminal, which you can probably check out here. This is, if you haven't seen it before, a really awesome way to interact with the command line on Windows. And here I have a drop-down, and it actually shows all of the different things that I've installed. These are shells, so like Command Prompt, PowerShell. The one that I'm looking at today is Ubuntu. So I'm going to open that, and from here, I'm going to go to this folder that I have, which is where we're going to actually be doing our coding for today. And it's called Deep QLearning because we're going to be teaching a machine to play Atari using an algorithm called Deep QLearning. If you're not an expert on AI and ML, that's totally fine. You don't need to be, we just want to do a fun example. And so normally I could go in here and do things like LS, or I could Vim and start editing stuff. But I really want to use VS Code because I absolutely love its editing experience. And all I have to do is hit code dot. From here, a lot of magic happens. We basically get set up using VS Code Remote. And how we know that is because if I take a look at the bottom right, you can see this magical WSL Ubuntu here that shows that I'm actually running this directly inside of my Linux instance. However, everything on the UI side is running on Windows itself. And why that's important is because all of my extensions, any visual themes that I might use, they're all consistent across Windows, across Linux, even all my different Linux distributions. So where this really matters for me is I actually have an extension installed called the Vim extension. And this just lets me do keyboard shortcuts to program really fast. So for example, if I wanted to select this line and then select 10 lines up, all I have to do is hit some quick keystrokes, don't touch my mouse, and I can do that, which is why I use it. And that basically transforms your keyboard to work in a different way. And that's consistent for me now across Windows, across Linux, across any project that I'm using, which is awesome. And if I actually take a look at these files, you can see it's probably going to be really tiny on your screen. But let's make it a little bit bigger. Let's see if you can really see it. Close. You can see that the file ending for this file, or actually its path, is a Linux path, right? It's /home. This is actually really Linux. And then if I go and hit Control tilde on my machine, that will open up the integrated console, and I get my exact Linux console, right, that I had here before, which is pretty sweet. So it's a really powerful way to use this directly in a Linux environment. What we're going to do is we're actually going to take it one step further. I'm going to use development containers to actually do my work. Why this is the case is because for using AI and machine learning, it's really cool. It's something that I don't do that often, though. And so I don't want to have this all installed on my machine for the rest of the time. I would rather just package this up into a container, do my development in a container, and then afterwards I can just delete it and have a really clean base environment, which sounds preferable to me. And so literally to get this project set up to do that, all I have to do is hit Shift-Control-P, and I'm going to open up my command palette, and I'm going to hit Reopen in Container. From here, the same kind of magic that happened when we ran Visual Studio Code Remote is going to happen here. It's going to start up a container, and I can hit show log and see what it's doing. It looks really complicated, but at the end of the day, all that it's doing is starting up this exact same environment. So everything looks exactly the same. I'll close these recommendations. But now we're inside an actual container. So you can see that the path changed because I changed it inside of my container. And when I go and hit Control tilde and open up my terminal again, I get this cool TensorFlow logo, and now I'm the root user. So I basically just changed where I'm developing, and then this container has all of the tools set up that I need, all of the really intensive tools. Like it has CUDA, it has TensorFlow, it has everything that I need to go develop my container, my machine, or my project without worrying about it being actually on my machine. And what's cool is I can go back here and I can run Docker container PS. This is just going to show me what containers are running, and you can see this VS Code container is running right here. And if you haven't seen this before, with the power of WSL, I can run PowerShell.exe. So now I'm in Windows land, right? Like this is the exact same as going to this tab. And then I can run Docker container PS, and I see the exact same container. So no matter what workflow I'm using with WSL, I can basically enjoy using this on Windows, using this on Linux. It all works exactly the same. So even if you're not really comfortable with the deep Linux command line, or using a Linux shell, you can still boot up into remote containers really easily using totally Windows tools like PowerShell. And now I hit exit, and I've jumped back to Linux in this terminal. Well, let's jump back over, and let's actually run this. Before I jump into how everything works, let's do what every great developer does and just hit F5 and see what happens. So I get my Python file, debug info. I hit F5. It starts a debug session here, and then you're going to see a lot of text spew out on the output. This is because we're actually setting up WSL to use your GPU using TensorFlow. And here we go. We have Atari, and we have a AI playing it. I swear I'm not playing Atari. My hands are up here. And it's actually quite good, which is really cool. And what's actually going on here is we have an app running inside of a Linux container, which is running inside of WSL. And I, on Windows, am remoting straight into that container, and I'm running my app there. And on each frame, we are interpreting what is happening on the frame. Whoops. We're interpreting what happens on the frame, and we are choosing an action for it. So at a base layer, the AI is saying, hey, I see that I'm about to miss the ball. I need to output the action of moving left. And if I go and take a look at my system, task processor, you can see that my GPU usage has gone up, and I'm actually stressing the GPU here because I am actually using my Windows GPU to power this in a performant way, which is really powerful for if you wanted to actually do training on this machine, which you can do as well. And the last really cool part here is let's take a look closer at this window. For any Linux fans out there, you might notice that this is a GTK-based tiling here. This isn't Windows tiling. Why is that? This is because we are actually running this as a Linux GUI app. WSL has support for Linux GUI apps. I can show you really quickly what that looks like. If I hit gedit, which is not installed, that's fine. If I hit xeyes, the old standby, then you can see I have a Linux app here running straight from Linux. with Linux tiling at the top, and I can run that directly inside of WSL. This is now supported by default on Windows 11. And what I've done is I've actually piped that information to this container, so I can access that same server. Okay, now the point is, how did I do this? What did I do to set this all up? Well, there's a .dev container folder here that has all the magic. If I go into this and I look at devcontainer.json, you can see the setup that I use to set up this development container. So I have my Docker file, which is referenced right here. And I have my settings of, what arguments I want, what my workspace folder is. I even specify the extensions. So the Python extension is installed by default. Let's take a look here. You can see Python is installed here by default, and my Vim extension is still installed. So all my themes are the same, which is awesome, even if I'm using different debugging tools. And then there's also mounts. So we're actually mounted the exact same folder that we have in my Linux instance, which I'm used to using, into this instance here. So for example, I'm just going to go in and say, hello world, and we're going to choose, some file.txt. So that just made a file inside of my Linux instance from normal, and I get access to it here right away. And of course, any changes that I make here will change my source folder inside of my Linux distribution automatically. So, and then the last one here is I put this in as well. This is a bind mount for, you'll see that it says .x11 Unix. And there's actually a Unix socket that we use to basically forward graphical information to facilitate GUI apps. I just forwarded that socket into the container as well. And so it's actually sharing the same socket as my Linux instance. And so anytime that this container says, give me a graphics app, it forwards it to my actual WSL instance, letting me run graphical apps from here. And then the last part of this is if I go and take a look at this container at the Docker file, you can see that I added an, I use the automatic setup, which is really cool. Like you can basically hit Shift-Control-P and do, create remote container. If you search remote in this, you can basically find all of the really cool extensions here. And I use that setup to automatically create this. And then I install some specific things at the bottom here to set up my environment. And so the last, one thing that I forgot that's important. This project is part of, it's from someone else's code, user BOYUANF on GitHub, their deep QLearning project. I basically took that, cloned it, and added some changes. And so for you machine learning fans out there, I changed it to a dueling queue network. And if you're not a machine learning fan, that's totally fine. Basically, all you have to know is that this code is basically interpreting that image and taking a look at it and then determining what's the advantage. So what's the advantage of me making an action right now? And then what's the output that I should do? But that's not fun. Let's actually debug this. So I'm going to go here. I'm going to uncomment this, comment this, and then let's set a breakpoint somewhere. Why not here? And we'll see what happens. So if I hit F5, I'm going to debug this on my Python file, and we're off to the races. So again, this is going to take a little while to start up because we're passing in the GPU. There we go. It went quite quick. And you can see my GPU devices here. And what's cool is I'm in a remote container, right? Like I'm not actually technically on my machine, but I get the exact same experience as it is on my machine. I can go in, I can step through anything, I can do full debug information here, right? Of my score, the model, everything. And I can debug this exactly as it was running on my machine, which is really powerful because this isn't something that I want to run on my machine all the time. This might be something that I want to run somewhere else for heavy training. And so I can go ahead, debug this, and step through the whole process and run everything that I need to. And where that gets to for the last part is exciting, is that I can actually package this entire project, and I can put that into a Docker file, because it already is using containers. And then I can go ahead and toss it up into Azure. So I put this into the Azure cloud. You can see it training here. It's running on a beefy computer with like 13 gigabytes of memory is what it's using right now. And I can go in ahead and take a look at containers. The UI is going to be a little small, but that's okay. And I can connect to this container running now in Azure. And it's doing the exact same workflow. So it looks super similar because it is. And it's doing the exact same workflow, right? If I do tail out.log, so this command is just showing me the output of it. You can see the exact same output that we had before on my VS Code instance here, working directly here. So, my step, my episode number, the score, the loss that I'm seeing on my container, the time that it's been running, etc. And so this is actually how I trained this instance. I didn't actually run it totally on my computer. I ran it to verify it, and I ran some other smaller models on it. But when I was like, okay, I'm ready to do this on a really beefy computer, I was able to just really easily push that to Azure. And then on Azure, run this entirely in a container incredibly easily. And then the last part of here that's really cool is there are other extensions that I don't even have installed normally on VS Code. An example is because I don't do machine learning and AI all the time. I don't have Tensorboard installed on my normal VS Code instance. However, in this remote container, I do. So I can actually install other extensions that I wouldn't normally have. So we're going to open up Tensorboard. And Tensorboard is just an application that shows you information about your running sessions or your past sessions for machine learning. And so it does things like, this list here is my list of sessions that I've run and I've trained locally on this. And I can do things like change the smoothing operation of it. So I'm going to really make it smooth. I can change the horizontal axis to see when I did everything, etc. So this lets me go in and take a look at this information really quickly, and a really cool extension. And I don't have this installed normally on VS Code, but because I'm running this in a remote container, VS Code is super smart and is able to say, hey, yeah, I see that you're running this awesome workflow. Let me make this recommendation to you, and run Tensorboard in it, just like it would normally. So at the point of the end of the day, it runs exactly like it would on my actual machine. Very similar in terms of performance, being able to run things, and even running Linux GUI applications, which is super, super, super cool, because this machine learned how to play Atari Breakout on its own. And we have some time, so I just want to give a quick overview of actually what's happening, because I think it's super cool. This is a model that was developed by Google's DeepMind. It's part of a research paper. What it does is it takes in, you can see that it basically takes in this first layer, is taking in a picture of the screen. It's actually taking 4 pictures stacked on top of each other, so it can get an idea of what's moving where, right? And then we're doing all this crazy math inside of this brain, basically, to output our actions. What's really cool about this is most machine learning is done where you have a training data set and you have a model, right? You show it. You're like, this is a dog. And it goes, okay, I got it. That's a dog. Like, this is a cat. This is a car. And then over time, it learns, right? Based on you telling it. The cool thing about this algorithm is that it is doing everything based on reward. So what it's actually doing when it's stepping through this code is we get what action we should do. So at the beginning, it starts off totally random. And then over time, as it learns how to play the game better. And then we get a reward from our environment. So based on our actions, we get points. And the reward in this case is just the score, right? It says it's literally as if you were playing Brick Breaker and you were moving around, had no idea what was going on. And then you saw the ball hit the top and it gave you a score of 10. You go, oh, I get it. And that's what we're simulating here, basically, with this AI. No one is teaching it how to play this game. It's actually learning it totally on itself just to maximize that score value at the top, which is really cool. And while we're on the train of explaining how things work, I will really quickly go into how this is all working behind the scenes for WSL, because it's also super interesting. Basically, what we're doing here is this diagram. So this is an architecture of the Windows Subsystem for Linux, specifically for Windows Subsystem for Linux 2 type distros. And we have our hypervisor is at the bottom. So we actually run in a virtualized machine. Everything that we're doing right now is using virtualization. And this hypervisor runs actually below the OS on Windows. And here's our Windows OS, right? The Windows kernel, Windows user mode space. And then here's our Linux instance. So this is everything that's running on Linux. The magic here is this green arrow in WSL. We basically have a lot of different connections, so you can access files. You can do that thing that I showed of running PowerShell.exe directly from WSL, or Docker that attaches to both, right? It makes it really easy to go and move in between. And VS Code is part of this family too, right? You saw how easy it was for me to move between Windows user mode, which was the actual VS Code window, right, is on Windows. But everything on the back end, everything that was working was all inside of Linux. So here's the really complicated diagram. I'm going to put this up and you can pause and take a look at it later. But basically all you need to know is that we have this virtual machine. It's the exact same as before. And all of these distributions are running inside of the same VM. And then for GPU compute, right, we have that data. You normally have a data talking to a machine learning algorithm that gives an outputs a trained model. That machine learning framework is what that algorithm depends upon. So an example that I used, you saw TensorFlow a lot. TensorFlow is the framework, right? I called into TensorFlow to make my model and to train it. And so that framework, like TensorFlow, it depends on a hardware acceleration API. So I mentioned CUDA as one, or DirectML. These talk to your graphics card, which is the last step here. And so we actually changed this middle layer. We changed how Linux was talking to your graphics card, and we made it possible for, if you're running in a WSL instance, when you call into CUDA or DirectML system calls, that they call directly to your Windows GPU, and it's all shared, right? I didn't have to pass my GPU. I only have one, and I was able to train fully off it. And the last one is Linux GUI apps. So I showed GUI applications working. How does that actually work behind the scenes? Like, what's the magic behind that? So you remember this diagram, the really complicated one? Okay, let's make it easier. I got rid of a bunch of stuff. I'm going to run really quickly through all this, by the way, and you feel free to go back and take a look for more in-depth explanations and views over it. But basically, all you have to know here is we have Linux on the right and Windows on the left. I'm going to simplify this a little more and get rid of kind of all the other info. And what we've done is we've made a system distro in here. This is kind of like a companion distro to your regular one. So when I opened up Ubuntu and ran it, we had another like mini distro running way behind the scenes. This mini distro runs a Wayland server in it. Wayland is just a way that you can have Linux GUI apps working on your machine, basically. It's like a server to facilitate GUI apps. And when I go in and run an application in Ubuntu, like in this case, the Atari Brickbreaker or Nautilus in this example, it goes and talks to this Wayland server. And that's really the main things that you need to know, is that Wayland server then uses the power of WSL, like that green arrow we talked about before, to use an RDP connection over a hypervisor socket, and it goes and talks to mstsc.exe. And that is the same program that you use to do like remote into your other machines and things like that. And so we remote the instance of the Linux GUI app onto your machine, and then that is what controls the rendering and everything on the Windows side. And then, bam, you get your Linux GUI app rendering right alongside your Windows Linux user apps as well. So that's the simplified version. And the last part of this is that if you go ahead and run something like another app or distro like Debian, or in this case, like other containers and things like that. If you run other WSL distros, you will get more system distros. And then when we ran in their container, we basically piped out to access one of the Wayland server inside of that distro. And so here's, this is the simplified version. So if you take away anything, just take away this. For people who are really interested, these are all the bits and pieces. So we have a Western server talking to an X-Wayland server to host X11 apps. We do audio with Pulse Audio, and then that talks over FreeRDP to communicate to mstsc.exe. So feel free to pause and really take that in after the talk. And then that is the highlight of everything that I wanted to show you, the A to Z of how to run Brickbreaker.
Awesome. Thank you so much, Craig. I should have paid more attention to my OS architecture class in college, but that was a really good kind of overview of what's happening underneath. You're having this fairly native experience and it feels very easy to connect to all these remote environments, but there's a lot happening under the scenes.
Yep, totally. And it's really cool. As you said, a fairly native. Everything that I did would look exactly the same as if you're running on Linux, which is really cool.
Awesome. We have a couple of questions, actually. So William has a couple of questions. First, what you showed with Azure, what would be the cost of that ML model that you were showing?
Yeah, so it depends. It depends on the resources and everything that you're using. What's cool is you only pay for what you use at the time. So you only pay while it's training. Okay. I think what it costed me specifically when I ran this was $20. To run this for 4 days over the weekend to actually train the model that I showed.
All right, cool. And William also asked if you recommend any resources because he's been having some trouble getting his WSL instance to run GUI apps. Do you recommend any Microsoft-related docs or tutorials? Yeah,
I would recommend please take a look at aka.ms/WSLG. This will take you to the actual web page. Actually, you know what? Let's do this. There we go. So this will take you to the GUI, the GitHub for Windows Subsystem for Linux GUI apps. It has all of the install instructions here of how to get set up and get everything running. And then if you can't, and if you run into issues, please go here, file an issue, and we take a look at these boards and we'll be able to help you out.
Okay, awesome. And then Steven asked a question about if he has multiple projects, like a Node.js project, a Java project, what would be the sort of the best practice? Just one WSL image for all of them, or for every project a new one?
Yeah, it's kind of up to you. Best practice is, I think in that case, kind of fuzzy. For example, let's say I go here and I have another Node.js project. For me personally, I love the container workflow. I'm so happy to go and use containers for all that stuff, especially if you have a lot of different tool sets. It's a blessing for me because I do a lot of demos on different tool sets. I use Node.js one day and then deep machine learning on another day. So having everything containerized that I can just pull it down instantly is awesome for me. But for you, if you're using, let's say, everything totally on the same machine and consistently, just put everything on the same image. And you could even, if you want, have multiple WSL distros like this Debian distro, and go ahead and use this as another staging ground of I do all my Node.js work in Debian, and maybe I do all my machine learning in Ubuntu. It's kind of up to you. I think there isn't a hard and fast strict best practice there.
Okay, awesome. And then lastly, everything you showed us, the Linux GUI apps, the GPU acceleration, when is that available? When can people start building?
Yeah, so if you want to get it right now, please join the Windows Insiders program and head on to the dev channel. You can see that I am on lovely Windows 11 here, given my taskbar. It's all available. Thank you. It's all available on Windows 11. As part of Windows 11, once that's generally available, these features will be available. If you want it now, join the Fast Insiders program and get on the dev channel.
Okay, awesome. And one more last question, because we do have a couple more seconds left. But there's a big hype around code spaces as well. So can you tell us is there a relationship with code spaces and WSL with what you showed us?
Yeah, what's cool is code spaces, if you haven't heard about it, is basically the exact same demo that I showed of running all of this in containers and remotely, but in your browser as well. So imagine if I had this project up on GitHub, you could go in and just click open this in code spaces. In your browser, you get that VS Code instance, and then you get to run through the container and all that workflow and have all the extensions and everything like that. The exact same user experience, but directly in your browser without even having to download anything on your machine, which is super, super cool.
Yeah, that's really awesome. Just the direction that kind of development has gone in over the last couple of years is the fact that we can even do something like this is pretty incredible.
It's pretty awesome.
All right. Well, thank you so much, Craig, for joining us today. Folks, if you have questions, like Craig said, go over to the GitHub repo and open up issues, ask questions. I'm sure they'd love to hear from you all.
Yep. And if you have any specific WSL questions, take a look at Microsoft/WSL for general WSL. And if you have any other questions, you can follow me on Twitter at Craig A. Lowen on the screen.
Awesome. All right. Take care, everyone. Thank you for joining us.
Thanks. Bye-bye.